For centuries, people believed Earth stood motionless at the center of creation, while the sun, planets and stars revolved around it. This idea, known as the geocentric model, was supported by philosophers, scientists, and even the Catholic Church. To most people, it seemed obvious. After all, the ground beneath their feet felt perfectly still. But in the early 1600s, one man pointed a small telescope toward the sky and changed history forever. That man was Galilei. Using a telescope far more powerful than earlier versions, Galileo began observing the heavens with incredible detail. What he discovered would challenge centuries of belief and ignite one of the greatest scientific revolutions in human history. One of Galileo's first shocking discoveries came from the moon. At the time, many believed heavenly bodies were perfect and flawless. But through his telescope, Galileo saw mountains, valleys, and enormous craters covering the moon's surface. The heavens were not perfect after all. Soon after, he turned his telescope toward the sun and noticed dark spots moving across its surface. Today we call them sunspots. This proved that even the sun changed over time and was not an unchanging divine object. But Galileo's most important discoveries came when he observed Jupiter and Venus. On January 7, 1610, Galileo aimed his telescope at Jupiter. Beside the giant planet, he noticed several tiny points of light. At first, he assumed they were distant stars. But over the next few nights, he realized something extraordinary. These objects were moving around Jupiter itself. Galileo had discovered 4 moons orbiting Jupiter. Today, these moons are known as the Galilean moons: Io, Europa, Ganymede, and Callisto. This discovery was revolutionary because it proved something incredibly important. Not everything in the universe revolves around Earth. If moons could orbit Jupiter, then Earth could no longer be considered the absolute center of all motion in the cosmos. But an even greater challenge to the old model came from the planet Venus. When Galileo observed Venus over time, he noticed it changed shape just like the moon. Sometimes it appeared as a thin crescent. Other times it looked almost fully illuminated. These changing appearances are called phases. In the old Earth-centered model, Venus was supposed to remain between Earth and the Sun at all times. If that were true, Venus should only appear as a crescent and never show a full phase. But Galileo observed every phase of Venus, from thin crescent to nearly full. This observation perfectly matched the heliocentric model proposed by Nicholas Copernicus, which stated that planets orbit the Sun rather than Earth. According to this sun-centered system, Venus sometimes moves to the far side of the Sun from Earth, allowing us to see its fully illuminated side. Galileo's observations provided powerful evidence that the heliocentric model was correct. However, not everyone accepted these discoveries. At the time, the Catholic Church strongly supported the traditional Earth-centered view of the universe. Many religious authorities believed that placing the Sun at the center contradicted Scripture and threatened humanity's special place in creation. Galileo's ideas quickly became controversial. There were also scientific objections. People wondered, if Earth is moving at enormous speed through space, why don't we feel it? Why does a dropped object fall straight down instead of flying backward? Galileo attempted to answer these questions with experiments involving motion and inertia. He explained that objects move together with Earth, so we do not notice Earth's motion. These ideas later became foundations of modern physics and were expanded by Isaac Newton. Still, direct proof of Earth's movement was missing. Scientists predicted that if Earth orbited the Sun, nearby stars should appear to shift slightly during the year, a phenomenon called stellar parallax. But telescopes of Galileo's time were not powerful enough to detect such tiny movements. That proof would not arrive until 1838, when Friedrich Bessel successfully measured stellar parallax for the first time. Galileo himself was not correct about everything. He mistakenly believed ocean tides were caused by Earth's motion rather than the gravitational pull of the Moon. Yet, despite some errors, his observations transformed humanity's understanding of the universe. In 1632, Galileo published his famous book, Dialogue Concerning the Two Chief World Systems. The book compared the geocentric and heliocentric models, but it clearly favored the sun-centered view. This angered church authorities. Galileo was eventually put on trial by the Inquisition and forced to publicly deny support for heliocentrism. He spent the rest of his life under house arrest. But history would prove that the core of his discoveries was right. With a small telescope and relentless curiosity, Galileo helped humanity realize a profound truth. Earth is not the center of the universe. And from that moment on, science would never be the same again.